Okay, Transmath 2 class, this is your video lesson for the notes for 2.5. Okay, so some more of these problems where we have some inequalities, so we want to determine, looks like these are all less than signs. We want to put the smaller fraction on the left and the larger one on the right. Okay, and I think, I guess not all of them have improper fraction, but most. So the 10/10, which is improper, that one's going to be the bigger one, so I'm going to put that over here. 1/5 is the smaller, that's the proper fraction. In this one, 5/5 is improper, so that's going to be larger. And 3/4 is a proper fraction, so 3/4 is less than 5/5. Okay, over here, they're both proper fractions, but I think we can maybe figure this out. When I compare 2 and 6, okay, 2 is closer to 0 than it is to 6, right? So it's closer to 0 than it is to half. On this one, 11/12, well, those are really close together. Okay, so when we were doing those activities, where is it relatively large or small? This is definitely relatively large because 11 is very close to 12, which means it's a large fraction. So we're going to put that over on the bigger side. 2/6 is relatively small because 2 is small compared to 6, where 11 is pretty large compared to 12. Okay, and on this one, again, if we have a improper fraction, that's definitely the bigger one. So 4/4, which is equal to 1, is going to be the bigger one. The 2/3 is going to be the smaller one, so it goes on the left. Okay, so here we want to write 3 common multiples. So again, when we're doing these multiples, so for example, 6 is a multiple of 2 because 2 times 3 is 6, right? So then we can just count by 6's. 6, 12, 18. Those would be 3 common multiples. Now when I look at these ones, 4 and 6. Now 6 is not a multiple of 4 because 4 times 2 is 8, right? So it's not 6. But what if I take 4 times 3? That gives me 12. Now is 6 also a multiple of 12? Well, 6 times 2 is 12, so yes it is. So that means we want to go by 12s on this one. 12, 24, I guess it says we only have to do 2 on this one. Okay, 3 common multiples here. Now what I always want to say is the bigger one a multiple of the smaller? Is 8 a multiple of 2? Well, 2 times 4 is 8, so yes it is. So we're going to count by 8s. 8, 16, 24. Okay, and same question here. Is 8 a multiple of 4? 4 times 2 is 8, then it is. So we're the same thing, we're going to count by 8s. Same answer as the last one. Okay. Alright, so here it says show a proper fraction, 7/8 on the number line, and then the improper fraction, 6/5 on the other number line. Okay. Well, 8ths, I'll do that here. We're going to cut it into 4ths first, and then we're going to cut each of those. So now we have 8ths represented on our number line, right? So I want to represent 7/8. So I'm not going to label all of them, but 1, 2, 3, 4, 5, 6, 7 would be the one right there. So that's 7/8 because we know that the 1 is the same as 8/8, right? Now over here I need to do 5ths because the 5 is the bottom number. So I'm going to try to break this into 5 equal parts the best that I can. So something like that. And now as I go through this, right? 1/5, 2/5, 3/5, 4/5. This is 5/5, right? So 6/5 has to be over here, right? 6/5 right there. So 7/8 is there, 6/5 is here, and if we were to compare those, I think we could see that 6/5, which is improper, is greater than 7/8. Okay. This concept is just that, there's an infinite number of fractions between 0 and 1. We could make this, we could cut it into 10 equal parts. We could cut it into 20 equal parts. We could cut it into 100 equal parts. But, theoretically we could do that. But, the number line gets, when you have your pen, it's going to start getting pretty crowded in there. But the idea is that we can make things as small as we want them to be, right? It would be a mess to try to divide it into 100 equal parts because that would be really crowded in there. What would 100 equal parts look like? What would 99 parts look like? Okay, so just getting you to think about those things, right? So proper fractions, that are between 0 and 1/2, they're going to have us fill in some of these things. So if we decide that it's less than 1/2, we're going to put it in this box. If we think that it's bigger than 1/2, but less than 1, so it's still a proper fraction, we're going to put it in this box. If it's equal to 1 or greater than 1, we're going to put it over here. Okay. So this is just an example here. So 1 over 100. So when we compare 1 to 100, 1 is much closer to 0 than it is to 100. That means that it's definitely, definitely over in this box. It's not more than 1/2. That's definitely closer to 0. Now, 98 over 99. Well, 98 is still smaller than 99, but it's very, it's a relatively large fraction because it's very close to 1. 99 over 99 would be where the 1 is, right? So 98 over 99 is going to go in here, in this box. And then 47 over 2, well, 47 is much larger than 2, so it's an improper fraction. That would be over in this box, okay? Oops. Lost my pen. There we go. Here. It's loading. Give me 1 second here. Well, hopefully this finishes soon so we can continue with the video. Well, unfortunately, it looks like we have some technical difficulties, so I will probably have to stop at this point.